Students, in this video I'll explain you chapter number 8, electromagnetic waves. Actually I have already explained this chapter in the class, but the attendance was short, so I'll go through this chapter again. Okay, and in this chapter we will understand that this chapter is a total summary of all the chapter that we have studied. So it will be a revision for other chapter too that we have studied in this book. So let's understand this chapter. Okay, so electromagnetic wave. What are electromagnetic waves? As the name suggests, they are the waves. What is a wave that you have studied in class 11th? Okay, it is a disturbance. Okay, disturbance in a medium. Okay, and it goes from one point to another without the movement of the particles of medium from this point to this point. The medium of the particle, they will just oscillate. Okay, and the disturbance, the vibration, the energy will go from this point to this point. That is a wave. Okay, and in case of electromagnetic wave, this vibration are what? They are electric and magnetic field. That's why the name electromagnetic wave. How are electromagnetic electromagnetic waves produced? Okay, so basically this has been asked in the boards. Okay, so what the source of a electromagnetic wave? Okay, I'll just give you an example. This is a charge, okay, a stationary charge, and you recall from the chapter 1, what does a charge produce? It produces electric field that we have studied in chapter number 1 and 2. Okay, so it produces electric field. Okay, stationary charge. Okay, now this produces electric field, and in the second chapter we talked about to understand electric potential, that we talked about electric potential. Basically these two things are depict the same meaning, strength of a charge, okay, at a point. Okay, but this is vector and this is scalar. Okay, and we can connect them too. We have an equation. Okay, this formula that we have studied is equal to dV by dr, and this is what electric field is the negative gradient of potential. That is, electric field is in the direction where the potential decreases, that we studied in the second chapter. Okay, so positive charge produces electric field, that we studied in chapter number 1. Okay, and also the concept of potential. Okay, now in chapter number 2, what we studied, okay, just observe carefully. I'm revising you all the chapter, and you will come to know how this revision or all the chapter is connected to this chapter. Okay, the question, and also remind you the question I ask you, what is the source of electromagnetic wave? Now in the third chapter, what we studied, that was the current electricity, that charge. In the first two chapter, what we discussed that charges are stationary. We are electrostatics. We were concerned that the charges are stationary, not moving. Okay, but in the third chapter we studied that the charges now are in motion, and hence they will constitute electric current. Okay, charges will be motion, there will be drift velocity, all the concept is studied. Okay, the point is the charges now will be in the third chapter we talked about the charges in motion. Okay, and the fourth chapter give us this effect that moving charges constitute magnetic field. Okay, moving charges constitute or result in magnetism. So one thing is clear, moving charges produces magnetic field. Okay, next, in the next chapter we talked about the magnetism, and magnetism as a separate branch, not as an effect of electric current. Okay, then in the next chapter, that was the EMI, electromagnetic induction, very important chapter for this perspective. It sums this up, that we come to know that induced current, how can we produce induced current? So we had the Faraday law was there, electromagnetic induction, the Faraday laws was there. EMF is minus d phi by dt, and you remember I also told you all this in the beginning of the session. Okay, and I am also revising this too, because this is the basic idea, and all the things in this first book revolve around this idea. Okay, So d phi by dt, and mind you that this is not phi e, this is phi b, and you know phi b is magnetic flux. Okay, so d phi by dt is the rate of change of flux. Okay, so what happens, we see that whenever there is a magnetic change in magnetic flux, okay, there is a EMF produced. Told you the examples of magnet moving through towards a coil, closed coil obviously, then only current will be there. Okay, so this north and south pole, so this produces change in magnetic flux. Or what was magnetic flux? I told you they were the magnetic field line passing through an area. Okay, so there was a change in magnetic flux, and this constitute EMF and hence electric current. So the point here is, how can we change the magnetic flux? So magnetic flux is a formula, as you know, BA cos theta, where B is the magnetic field, A is the area, and theta is the angle between the magnetic field area vector, actually not area vector. Okay, and now how can we get this EMF? We have three different ways. Either we can have a varying magnetic field, and that is an important crucial point. Varying magnetic field we can have by area, changing the area, that was the motional EMF, and by changing the theta between the magnetic field and the area vector. Now varying magnetic field is, this should not make sense. Why? Because we know that very important concept for chapter 4 again. Can a magnetic field can exert force on the stationary charge? The answer, because you know the formula, F is equal to QVB sine theta, that because the charge has no velocity, so in that context, by this way, there should be no force on this charge. But what we are seeing that varying magnetic field, mind you, this is time dependent, that is changing with time. So it is exerting force on a charge on a conductor. In a conductor, this is a stationary conductor, and there are charges in this conductor, and this varying magnetic field is exerting force on this conductor. How can it be? Like I'm saying you that the magnetic field cannot exert for a stationary charge, and here a varying magnetic field is exerting force on a stationary charge. So these are contradictory statements. So what's the answer to this? So that because this is varying magnetic field, and hence what it does, it not directly exert force on the charges. What it does is creates an electric field. And mind you, this is different from electric field that we understand or studied from chapter number 1, that is from static charges. This varying magnetic field, what it does, this is, mind you again, that is varying magnetic field, not time constant, time independent. This is time dependent, that is, it is not constant, it is varying. So it produces electric field, and this is again, electric field is varying and it's different from electric field. It has some different property than the conventional electric field that we studied in the chapter number 1. Okay, so this electric field now, and we know the electric field, it can exert force on these charges, and then this exert force on the charges, and hence current is there. Okay, so varying magnetic field produces current, induced current, but not the way we think. It produces electric field, and hence if exert force on the charges. Now again, this electric field, because it is varying, there is a current. What it does, it produces magnetic field, again varying magnetic field, and hence again electric field. This cycle continues, and hence the explanation is there, electromagnetic wave. This is how electromagnetic wave propagate. Varying magnetic field produces varying electric field, varying electric field produces varying magnetic field, and so on. And now we can come back to the question, what was the source of electric charge? A charge which is accelerating. Again, I recall you that this is the question asked in boards. Accelerating charge produces what? It produces electric field that is varying. Okay, and that varying electric field produces what? Varying magnetic field, and so on, the cycle goes on. Okay, so this was the big idea of this. And in the electric field, what happens? An electric field tell you that it doesn't require medium. It can propagate in vacuum. Okay, earlier it was light is also electric. One more discovery was there by Maxwell, that there was a mystery around light. What is light? Some said that it was the particle, some that it is wave, but it comes out to be, as you will study in the chapter second book, it has dual nature. But one thing was made here, that it is actually electromagnetic wave. Okay, so it is, what is electromagnetic wave? The electric field is oscillating in this way. Okay, the direction of propagation, suppose this is in the x-axis, the direction of oscillation of the electric field is perpendicular to this direction of propagation. And also there's a magnetic field because of this electric field, or the varying electric field, and vice versa, that this will produce varying magnetic field, which is also perpendicular to both the two, that is the direction of propagation and also the direction of the electric field, and hence we have electromagnetic wave. Okay, and this is how our communication works. This network we send, the mobile signal that we send, it is all electromagnetic wave. And we will study about the chapter is divided into two parts, about the anomaly in the Ampere circuital law, again, which was removed by Maxwell by displacement current. And the second part is pretty easy actually, because it is just about the facts about the different electromagnetic wave. I told you the acronym for learning this, that is rich man in Venice uses extra gold. Radio, micro, infraviolet, visible, ultraviolet, this is X-ray, and this is gamma, and this is the increasing frequency, and this is the increasing wavelength. So radio wave will have the least frequency, gamma will have the highest frequency, and radio will have the longest wavelength, gamma will have the shorter wavelength. In exam, what can come in board, they ask you about, they can also ask you about the wavelength and frequency of a particular wavelength. Okay, that is the fact, that is a fact back portion that you have to learn. And the users can be asked, like, what is the use of gamma? It can be used to cure treatment, cancer treatment, X-ray, for fracture, okay, to detecting the fracture. Okay, ultraviolet sterilizing, okay, check the purity of ghee. Infrared, it is used for sending signal in what, because it is not visible. In remote controls you see, okay, and photography in fog, okay, it is also used there. Microwave for cooking, for communication is also used. And this is radio, also communication, this is used. Okay, the uses and how their properties can be asked. Okay, the weightage of this chapter is not much, I think around 3 marks. It is not, the unit is around this chapter, from my approximation, considered about 3 to 4 marks. Okay, so now this again we will this 4 equation of Maxwell are important. This 4 already studied. Apart from this was the Gauss law. Okay, Gauss law from first chapter, Gauss law from magnetism. This is Faraday law. Again, this is the modification that is a part, and I will make a separate video for this, or I'll explain you in the class, because the video is going too long. Okay, so this was, I hope this has given you idea. Those who have not present, you can ask the doubt in the class, and or on the second video I'll make. Okay, so thank you.